Hi, this is Mr. Brandrick. Welcome back to AP Statistics. We are in room 101 with my period 2 class. Today's lesson is brought to you by the Tampa Bay Rays, your baseball team if you don't like baseball. All right. Do you guys see that first rule? The general addition rule. We used that yesterday. If you were here yesterday, which I think actually all of you were here yesterday, which is amazing, back-to-back days, everyone here. I'm so happy. If I were to pull out an M&M, remember from yesterday's example, if I pull out an M&M and want to know the likelihood that it's red or yellow or blue, we just added all three of those. You remember that from yesterday? Hopefully that was like number 2, Roman numeral 1, okay, from letter A. Now that assumes something. What did that assume about M&Ms? What did that assume about M&Ms? An M&M is biased? Don't eat me. I can't be eaten by you. Well played, but no. It assumed they were disjoint. Right? If I pick out an M&M, could it be more than one color? No. So M&Ms, the color of them are disjoint. All right, which is why we use that formula. But if they're not disjoint, we have to use this formula down here, which has a little extra stuff in it. This formula here. It has the same beginning, middle, but the end is different. We're going to subtract out the probability of A and B happening. All right, this will make more sense. We're going to do an example near the end of class. All right, this will make a lot more sense, but I want you to see that is the formula we're going to use. All right? And that means we don't have to even think about if they're disjoint or not. If you know they're disjoint, then you can use this one every time. Okay? The one on the AP exam formula sheet is this one. You do. I'm going to give you a formula sheet for the midterm. I know. It's amazing. We just started needing it with probability. Okay. Do you guys see the conditional probability down here? So conditional probability means that something has already happened. The letter or the event that's after that bar means given that that has occurred. So this is said the probability of event B happening given that A has already happened. Okay? So that's what that vertical bar means, given that. All right? So that whatever is after the bar has already happened. I'm telling you it's happened. It's in the past. Okay? Here's the formula for this, and you will also get this formula on the formula sheet. We will do an example, for sure. Don't you worry. All right, I got a week to get that packet done. Now, I do want you to notice that little note underneath the formula where it says the probability of event A can never be 0. And the reason it can't is because since it's the given, we know that it happened. So we don't have to worry about dividing by 0. Okay? I know that's always a worry in algebra or calculus classes. All right? So we don't have to worry about that here in stats. Do you guys remember the rule we used for multiplication yesterday and used it this morning on the quiz? You multiply them together, right? Probability of getting a bell and a bell and a bell is you multiply all three. Now that assumes something as well. What did that assume about each of those boxes on your slot machine? That they're independent. That one symbol or one image on a box does not affect the ones after it. And that's true, right? That's true of a slot machine. If you think that you're, playing a fair slot machine.
Ouch.
Yeah, right. Careful. Slot machines, not really that much fun. Just say it. They're not fun. Don't do that. Don't waste your time.
No, it's fine.
Don't. If you went to Louisiana last night, hopefully you did not play slot machines. They're super boring. Okay. What if they're not independent events? Then we have to use one of these. Now, I'll be honest with you. The AP exam is not going to give you these formulas, like these two here. It's going to give you the one on the previous page, And all these here are just taking the previous page's formula and manipulating it. So reordering it. So using algebra. So what I actually am going to teach you to do in this class is to always use the one that's given to you on the formula sheet, put in what you know, and then use your algebra skills to solve what you don't. Okay? So even though I boxed them, I'm never going to use those. I'm never going to use. Never. Well, I don't want to say I'm not going to give them to you, because technically I am, because I'm going to give you this one. And if I give you this one, then you can manipulate it to rewrite these. No, it'll be on the AP exam, but I'm going to use it this way. I'm going to plug my stuff into here, and then if I happen to not know the numerator, then I'm going to multiply this to the other side. All right, use algebra. Does that kind of make sense? Trust me, we'll do many examples. All right, let's talk about independence. We already briefly talked about it, and you had to answer a question today on the quiz about independence. But today, I'm going to formally define it using formulas, mathematics. Okay? So I'm going to use these formulas today in one of our examples to determine if two events are independent or not. Okay? So we'll be using that today. I'm excited. Okay. Every year, I get a lot of questions about the difference between independence and disjoint, which is why one of the first quizzes you took on this had that question. Number 2 was about discussing what you know about independent and disjoint events. All right? And hopefully after today, you have a better sense of the difference between the two when we do our examples. And again, you're only going to build on this. Your knowledge is only going to increase on the understanding between the two. So with disjoint events, they'll never be independent. Because independence means that if one happens, the probability of the other one happening remains unchanged. So it doesn't change. All right, bless you. But if it's disjoint, when I tell you one happens, the probability of the other one happening goes to 0. So it changes. It goes to nothing. So that's why disjoint events will never be independent. Now the question I always get is, can independent events be disjoint? Okay, so the drawing without replacement, this, if you ever see without replacement, means when they pull something out, they don't put it back. Okay? If it says with replacement, they draw something out, but then they put it back. All right, think about if you're fishing and you catch a fish and you put it back. All right, that's replacement, with replacement. Swim, be free. No, I don't like to fish. If you do, that's great. I think fishing is super boring, but every time we drive home, we drive by our fish camp in our neighborhood, where it has like a little pond, a little deck to go out and fish. And my son is like, "Can we go fishing?" And I'm like, "No," because it's so boring. But my dad loves fishing. So once Henry's a little older, where I'm not worried about him like falling in or like hurting someone, we'll let him go fish. I won't be there. Okay. The last thing, tree diagrams. We're not going to do one today. We're not going to have time to do an example today. But tomorrow, we will do an example all together about tree diagrams. I would say if I had to pick a hardest question on the AP exam with this material, it would be tree diagrams. And not because you won't know how to do it. It's just because when you read the problem, does your brain think, oh, they want me to do a tree diagram? Or does your brain go, oh, I don't know what they want me to do? All right? And that just comes with experience. All right, so that's my goal before May, is so you can read the problem and think, tree diagram. Okay? So we won't do one today, we'll do one tomorrow. But these are amazing problems for multiple choice because the AP exam loves them. You have to do a lot of work for one little answer. All right? You'll definitely have a question on the quiz next week on a tree diagram. You have to make one yourself. Any questions so far? Any questions? Okay. All right, so I want to thank everyone for watching. Don't forget to like, subscribe, and click the bell so you get notifications every time I upload a new video for my 96 subscribers. All right, I'm trying to get to 100 someday. 100, please. We out.